The Artemis missions will eventually break Apollo 17's record for the longest stay on the moon, 74 hours, 59 minutes, 38 seconds, thanks to this lunar outpost, which will also act as a base for more extensive research. According to NASA, the camp would initially only support missions lasting a week or two, but as it expands and becomes more sophisticated, the agency wants to support troops for up to 2 months at a time. According to current ideas, a lunar cabin, an open-top rover like the ones used on Apollo missions, and anything resembling an RV that would give mobility and enable astronauts to live and work away from the base for days or weeks at a period are all being considered. According to Kathy Lueders, Associate Administrator for Human Spaceflight at NASA, with each new journey, astronauts will have an increasing level of comfort with the capabilities to explore and study more of the moon than ever before. We are developing the technology necessary to establish an unprecedented human and robotic presence 240,000 miles beyond Earth as the demand for access to the moon increases. The human exploration of Mars will be an even larger cosmic adventure thanks to our experience on the moon this decade. Finding and taking resources from the moon itself is essential to NASA's plan for the Artemis base camp. This might theoretically enable humans to stay on the moon for longer periods of time by reducing the weight of rockets carrying supplies that are launched from Earth. These resources can include oxygen, metals, water ice, and building supplies derived from lunar rock or dust. The Artemis program's schedule has gotten a little longer since it was launched in 2019. The initial version of the base camp was supposed to be set up by 2030, however an internal planning document obtained by the news source Ars Technica implies it might happen closer to 2034. Although it may seem far off, teams of scientists and engineers are already working diligently to realize the ambition of putting humans on the moon. For details regarding the Artemis moon base were revealed to us after speaking with some of these experts. At the spot near the lunar South Pole, NASA will look for essential materials. The South Pole provides astronauts with 2 essential components for a lunar base: periods of constant sunlight and deep craters with depths that have been covered in darkness for billions of years. The South Pole of the moon sees up to 2 months of continuous light each year as a result of the moon's tilt with respect to the sun, with the sun circling just above the horizon the entire time. The Artemis base camp can generate enough solar electricity with all this sunlight. According to Prasoon Desai, the Deputy Assistant Administrator of NASA's Space Technology Mission Directorate, the agency is now investigating designs that would support a solar array more than 30 feet in the air to make the most of the sunlight that is available. The same tilt that gives the lunar poles months of uninterrupted illumination also causes some of the moon's craters to have shaded regions that haven't seen the sun since the crater was formed. Permanently shaded zones are these extremely cold and gloomy craters where researchers have discovered signs of water ice. If this frozen water turns out to be readily available and abundant, it will be extremely beneficial for the people living at Artemis Base Camp as well as for refueling missions to Earth or to Mars. However, NASA cannot promise that there will be enough water ice on the moon, that it will be accessible, or that it won't contain any impurities that would need to be thoroughly cleaned up. Numerous NASA initiatives, including the Volatiles Investigating Polar Exploration Rover, or VIPER, will focus on these details as well as the location of the greatest deposits. It is anticipated that this mobile robot would travel to the lunar South Pole in the latter half of 2024 to look for water. Ben Bussey, the director of NASA's Lunar Surface Innovation Initiative based at Johns Hopkins University, says that if further research reveals that there is no water on the moon, then lowering the cost of rocketing payloads between Earth and the moon will become the key to establishing a lunar base camp. In other words, it would need to become much more affordable to get everything from Earth to the moon that is required to build and supply the base. Astronauts will be able to explore the moon from base camp thanks to a new rover. The first significant step toward building a base camp will be the Lunar Terrain Vehicle, LTV, which is expected to launch on a mission sometime after Artemis 3 in 2025. The new moon buggy will be controllable remotely, and the rover will have some autonomy in avoiding obstacles like rocks and craters, according to Greg Chavers, director of the Technical Integration Office in NASA's Exploration Systems Development Mission Directorate. As a result, astronauts will be able to explore the lunar environment both from the base camp on later missions and from the security of a lander on earlier flights. This implies that NASA can use the LTV to carry out mission or science-related tasks even when no humans are present on the moon. The LTV will be essential for finding water ice and other lunar resources whether or not a driver is present. This will assist NASA choose the optimal location for the base camp's more permanent components. Without spacesuits, astronauts will be able to explore the moon. Although the autonomy and remote control capabilities of the LTV are significant innovations, its basic architecture isn't anticipated to differ significantly from the rovers that came before it. The open-top LTV requires astronauts to put on their spacesuits in order to operate it, which is where NASA's idea for a lunar mobile home enters completely uncharted ground from an engineering perspective. The pressurized interior of NASA's RV-like design, known as the Habitable Mobility Platform, will contain life support systems, allowing occupants to comfortably travel within without spacesuits on. As putting on a spacesuit can take hours and is not always pleasant, this makes life easier for the astronauts. It also implies that crewed ventures across the lunar surface can continue longer and travel farther than ever before. The length of each astronaut's oxygen supply in their spacesuits determines how long a mission can survive in unpressurized rovers like the LTV. The aim is to enable numerous astronauts to live and work inside the vehicle for up to 2 weeks, but the final design for the RV hasn't been decided upon, so experts can't predict what it will look like. After the LTV makes its debut, according to Chavers, the livable mobility platform will be delivered to the moon between 1 and 3 times by Artemis. Chavers states that when the first mission of the livable mobility platform is complete, the vehicle will stay on the moon for use in subsequent missions. The base camp's appearance could be shaped by lunar rocks and dust. Since science fiction has been imagining what homes in space might look like for decades, the lunar cabin is ready to capture the attention of the entire world. Although the design has not been completed, according to Chavers, NASA is considering inflatable and modular structures as options to build larger habitable rooms on the moon that are portable and low in weight. Chavers also highlighted a massive 3D printer that runs on moon dust or rock as a fascinating potential. He claims that a device like this might produce bricks or other shapes and either build a home from start or improve one that was imported from Earth. In fact, according to Chavers, a test structure is being constructed in Houston using a prototype 3D printer. According to University of Notre Dame geologist Clive Neal, who has researched lunar dust samples, moon dust or rock may be particularly important in protecting astronauts from radiation from cosmic rays and solar flares. The majority of this hazardous radiation is filtered out by the atmosphere and magnetic field of Earth, but the moon lacks both, so any humans who choose to stay there must take additional precautions. According to Neal, up to 6 feet of lunar material may be necessary to give astronauts adequate shielding from radiation, which can raise a person's chance of acquiring cancer at high dosages. We traveled all this way to explore the moon, but the most significant thing is that we discovered the Earth, said Apollo 8 astronaut William Anders when he saw our home planet rise over the lunar horizon, according to Mere Harmony. NASA keeps using the word sustainable in relation to the base camp concept, the woman continues, and I wonder if trying to use lunar resources to make our presence on the moon sustainable might make us think differently about the sustainability of our presence here on Earth. This is all for today. Thank you for staying with us. Don't forget to like and subscribe our channel. See you soon.